Good day, everyone. Welcome back to our channel. So, in this video, let's discuss how to create a realistic knurl. But before we go on creating or drawing a realistic knurl, let me discuss with you a bit, of course, what is knurling before we go drawing a knurl. The statement states that in manufacturing, knurling is a finishing process used to create any combination of horizontal, vertical, or crossing lines on the surface of the workpiece. For example, if a manufacturing company wants to add a diamond pattern texture to a product or a component, we use a knurling tool to create the design or the pattern for that matter. And when we talk of knurling, it can be done using a machine or by hand. What is the purpose of knurling? Why should we knurl a surface or a part of a project for that matter? Knurling can enhance aesthetics of a product by introducing an attractive pattern to its surface. Well, of course, you will agree that textured finishes are more attractive than smooth finishes. And another thing, if a part or a component of the hand tool has a knurl, then we can use, or we can use the knurled surface for gripping purposes. No? Why? To improve their performance or usability. You see? So if a hammer has a smooth grip, the users may hand slip while attempting to hold and use it. No? So these are probably could say the main purposes of knurling. Now the question is, how deep is a knurl, or how deep is the impression? Now we know that when we say knurl, it could be fine, medium, or coarse. Now for fine knurl, it is between 0.01 to 0.015 of an inch. Medium, 0.015 to 0.025, and of course, coarse knurl is between 0.025 maximum of 0.035 of an inch. And the statement states that, of course, if you know how to use the lathe machine, the procedure is to go all in. In other words, you may move the cross slide or adjust the squeeze to the fold depth right from the initial contact. Okay? What are the typical knurl sizes? Now we're talking of knurl sizes on the English system. But if you want, you can refer to tables that is for the metric system. Now here, since we're talking of knurls in terms of the English system, we have here standard diametral pitches 64, 96, 128, and 160. A large variety of knurl blanks are regularly carried in stocks, ensuring fast delivery on special knurl made to the specification of the customer. 64, 96, 128, and 160. And when we talk of knurl, we have three patterns. We have the straight, diagonal lines, and diamond pattern knurls. And of course, the most common are straight knurl and diamond knurl. Let's continue. Now here are the patterns. Now, straight pattern, we have here the angular pattern, and then we have here the diamond pattern. Question: what is a 96 dp diamond knurl? How do you interpret that on the English system? For example, I would like to cut a coarse 1/2 96 dp knurl. If you notice, the diameter of pitch is given 96. I multiplied it by the diameter of the stock. That is the external diameter of the stock, which is 1/2. Then I have a 48 teeth on a 1/2 diameter stock. So it means to say that you cannot simply guess the correct number of teeth on a knurl. You need to compute it. Outside diameter of the stock multiplied by the given diameter of pitch, that will be the number of teeth. As on our example, that will be 1/2 times 96 is 48. Now here, I have here a table. I cut it short here, and I have here a 0.5. Diameter of the blank is 0.5. Okay? And then if we try to take the example, DP 96 here, the approximate depth of tooth or increase in diameter is 0.016 of an inch. And the number of teeth here, if you notice, if I go down and my stock is 0.5, I have a 48, exactly the same on our example. So, the example of a knurl we'll be drawing are the following. A straight knurl, coarse, 0.5 is the diameter of the blank, and 96 dp. So these are the given so that we can start our drawing. Okay? So let's start with our drawing. I open Inventor now. I start drawing here. Now I know that the diameter of the stock is 0.5, so I type 0.5, for example, there. I click on Finish Sketch. There you go. Let's say I extrude. Let's say extrude asymmetric, or symmetric, symmetric extrude. Now the height, let's say, is 5/8. I simply type 5/8 there. And then I click on OK. So this is how it looks like. And then let's say we have a chamfer value. We click a chamfer. I will chamfer this one. A value of, say, 0.03125. I click here and here. So this is our stock. I will create a drawing on this face, and then I will project the geometry there. After doing so, I will draw a polygon wherein 4 sides means square, and then I draw like that. Done. Now my question is, what is the depth or the height of the polygon? Since the problem states that course 1/2 96 dp there, the maximum depth is 0.035 here. But let's dimension this. We'll not maximize it, but we'll say we take a value of 0.032. We have a 0.003 difference. So this is what we have. Now I click on Finish Sketch. Okay. Now let me extrude. Let's extrude this one. Well, of course, with the cut option. And let's say the extrusion is, let's say, zero point 0.5 or 1/2. I click on OK. I have this. After that, we click on circular. We click on select feature or features. I mean, I select this one, and then I select the axis of rotation. I go here. I find the z-axis. Now the question is, how many of them? How many of them? Since we're cutting a 96 deep in knurl, and then the outside diameter of the stock is 1/2. That is 96 times 1/2. Then number of teeth is 48. 96 over 2 is 48. So I type here 48. And then I click on OK. So this is how our knurl surface, let's say we change, we make it good. This is how a knurl surface looks like. This is a coarse knurl, straight knurl for that matter. You see? So it's not difficult to create an actual knurl, a straight knurl for that matter. No? So this is how it looks like, okay? So a while ago I told you that the most common knurl is straight as well as the diamond knurl. This is how it looks like here. Okay. Now, on the next example, let's draw a diamond knurl. The given is still the same. Still on the English system. And then we have a 1/2 and 96 deep in knurl. Let me draw here the circle again. And that circle is, let's say, 0.5 diameter. Click on Finish Sketch. Let's say we go here. Let's make this one our, what you call this? View. Let's place it here. Now let's extrude this. Okay. Let's extrude this. Symmetric extrude. Let's say a value of 3h. I simply type 3 over 8. Okay, I have that. Okay. And then let's have a chamfer again. Let's have a chamfer. A chamfer of value equivalent to 0.03125. This and this. Okay, so I have it one. Now again, let me draw my sketch on this face here. Sketch on this face. Project geometry. This one. And then I draw a polygon. Now 4 sides, starting here, like that. And then let's have the distance again of 0.032. Now the maximum value is 0.035, and I have an allowance of 0.003 of an inch. So 0.032 here, 0.032. I will not maximize it. So I have that one. I click on Finish Sketch here. Okay. And then I go coil. I select that. I select the axis. Find the z-axis. Like that. Select the opposite direction. There you go. We go with the coil size and select revolution and height here. What is the height? The height is 3/8, right? That is the that is the that is the total length. And let's say the revolutions will make it smaller, zero point 0.2. And then I have a cut option here, and then I click on OK. So I have that one. See that? Okay. Now, the number of teeth is the same. 1 half by 96 is still 48. So I click on the circular array tool. I select this. I select the rotation, the z-axis. Make this one 48. There you go. So I have this. Okay. Now try to take a look at what I will do here. I will edit the extrude. Instead of 3/8, I'll make this one 1. I'll make it a little bit longer. So what I have is this one. Right? I have now the extrude. Okay? Now what will I do then? I'll use the mirror tool. I select the pattern. I find the mirror plane, which is the XY plane, and then I click on OK. Now this is what I have. See that? Now the next step is, let's say I click on plane, and then I select offset from plane. This plane here, I will go opposite there. So take note that is 3/8. The first one, 3 divided by 8, is 0.375 divided by 2 is 0.1875. So I type negative 0.1875. That is exactly halfway on this length here. I click on the check mark. There you go. Now I click on the mirror tool. I select the circular pattern. I select the mirror plane. And then I click on OK. It's a little bit... So what I have now is, if you notice, it's a diamond pattern. And take note that it is not pointed here. There is still an amount value, a very small amount, because the depth is only 0.032. If the depth is maximized to 0.035, then automatically this will be pointed there. That is why I give an allowance of 0.003. So I go back, I go here, I click on plane, I click on offset from plane, I select this, I type again. But see, now this one is correct, negative 0.1875, which is halfway here, so I click here. And then I select again the mirror tool. And then I will select this. I select this plane here. Again. Let's mirror. I will select that one, and then the mirror plane will be this, and then I click on OK. So a little bit slow, huh? It will take a while. So I already have this one. Try to take a look. You see, I have exactly a very good diamond pattern there. Now let me hide this, and then this one also. I will hide it. So I have this one now. Now let me draw a circle here. Let's say diameter of 0.375. There you go. And then I click on extrude with the cut option, and let's say the cut option is 0.1875 probably, 0.1875, something like that. And then I click on OK. And then I go on. I go mirror again. I mirror this. Mirror plane is XY plane here. I click on OK. So this is how the result. Okay, so here we'll change the material so that you can see it. We go with the material, let's say fine cream. There you go. So what you see now is a realistic knurl, realistic diamond knurl. You see that? There you go. So it's not that difficult, okay? So for those who like my video lecture or video tutorial for that matter, kindly click on like, share, and click on the subscribe button below. So thank you very much.